Hello, everybody. Today we will present you Mecanim, the new animation technology that will be part of Unity 4.0 release. We could go on for many hours talking about Mecanim. It's 5:30, so we'll try to just give the best quick overview we can. So first thing we will show you is a little game prototype. We have outsourced to a Montreal company, Behavior Interactive. So they took our technology and built a little parkour game with Mecanim. So Pierre-Paul will go around a bit to show you the kind of animation that we can do with Mecanim. On the top, we have a low-resolution screen. On higher resolution, you would see better the state machine that is currently evaluating. But with Mecanim, you can build complex animation controller to create run, cycle, jump, blending with idles. Everything that you are seeing right now can be built out of a user interface. Another interesting thing about this is that we gave them our assets that we used for a previous demo we did at GDC last year, but they were able to use their internal move like this wall run. It was from one of their games. So being able to take their animation and retarget it to our character. So in fact, they were also able to take their own character, bring it in the game, and see what it looked like. So, one thing that is funny to look at is the naughty bear. So, the same exact animation controller, the same exact animation are now playing on this bear. They are retargeted runtime. So, it's kind of fun to play with. Also.
Yep.
Whoop. Okay. So, Mecanim, how it works. So we targeted the biped animation, so humanoid character for 4.0. We have a little something at the end of the presentation on this. But the way it works is that you take a skeleton structure that is a humanoid character, and you in the model importer of Unity, you can create what we call an avatar object for it. So it will create a description of what your skeleton is. So here I have a folder with a... So I will take the bear and show you how we do this. So this is a FBX file we have imported. I'll go to the model pane. So in the model importer, you just specify that you want to create an avatar for this character. So now it is, I double click. It's not my mouse, it's a new mouse. Okay, and you know my project was supposed to have a non-created avatar because I want to show you how to create it, so we'll do the step back. So now I uncreated my avatar. Like I was saying, in the model importer, you say to this model, create an avatar. Here we have auto configuration mode. So we'll try to auto configure the avatar. So we'll try to match bone names and from the geometric structure, from the naming, from the topology of the skeleton. And here a little X appear here. It says that our automatic algorithm failed, but this is what I want. I want to show you quickly how you can configure an avatar manually. Don't save. So what is in green says, oh, we have detected all the upper body, but the lower body failed for some reason for that model. But what I did, there is many ways to associate body part to a human description. So here again, I have a very low resolution, but you have 19 bones. Require bones that you need to have in order to create an avatar. So you need to tell the system what bone is the hips, what bone is the spine. And usually the automatic configuration works. So you can also drop from the scene. You can pick bone from the scene, drop them in the right slots. What I will show you, we also have a name mapping structure. So let's say I clear all this, and I use an avatar setup. It's just a name template that was already created. So if in your game company you always use the same naming template, you can use this to auto create your association between bones and human body parts. So once this is done, your rig is almost ready to use. Here in the 3D view, we can see that there are some red parts. You need to set your character in stance pose in order to create the rig. For some reason, again, this model is a bit particular. This is why we are using it to show we can fix it easily. So you can enforce the bind pose and then enforce the T-pose, and we find the exact T-pose for that model. Then you can quickly validate in the muscle tab here if your animation rig has been correctly created. So I will try to make this a bit bigger so you can see. So we see the bear here, and we have we have preview slider that will show you the animation on the bear. So now the bear is doing a, if I unselect it, it will be better. So what I'm controlling here is all the muscles that are in the animation rig. We have created a rig where the body motion of a human is represented by muscles value. So here you see the different muscle below that are reacting when we are doing left and right, roll left and right. We have it for the fingers also. No fingers in there. So this is the process of creating an avatar. Once you have done this, you're ready to use your avatar with Mecanim. So in our demo, you could take your character, create the avatar, and you could play with it in the game instantly, the game we have shown you earlier. So this is the first workflow, creation on avatar. The other workflow is how you can extract animation from a FBX file with animation. How do you create your own retargetable animation? Before showing you this, I want to show you that not everybody will want to create animation. Many users will, what we have here is that you can browse the Unity asset store and find animation assets that are already available. So here it's in the project browser, but when you do a filter to search for animation, you can browse the asset store. So we've put some asset in there. So if I look, for example, at the jump, this is oops, I will just close the setup window before. So if I look at my jump animation, this is, again, from the asset store. You can have a live preview of your asset, of the animation that is on the asset store before buying it. So here we have another list of assets. those were provided by Mixamo. They gave us some assets, so provider can provide their animation asset and put it on the store. So I have a zombie run, for example, a death clip. And what is also nice about the previewing is if you have your own character, you may not be interested to look at the animation on this default character. So you can take, for example, let's take the bear here. So you just take the FBX file, you drop it here, and then you see the animation on your character. So before buying a move, you can already see if it works well on the character. So if I go back to my asset, one move that is kind of cool to show a Mecanim retargeting is the jump I was showing. If you look at the move, how the mass center and all this is preserved. So you can do it on the zombie run, on the death. So this is a way to quickly buy animation without having to go to a mocap studio or hire artists. You can have this on the asset store. If you have, now what I will show is how do you bring animation in Mecanim? How do you create a retargetable animation asset? Again, it's in the model importer. We have a folder here. Just let me reopen this. So I have a FBX file that comes from a motion builder. How do I, okay. And so as for the creation of an avatar, in the animation, what you do is that, okay, the workflow we propose here is that you may have your character that you are doing mocap on, and you have many files of mocap using that skeleton. So you define an avatar once, and once you have your avatar working, you are using it to do the retargeting and create the muscle animation. So in the importer here, I will say copy the definition from the Dude avatar. It is the avatar that was used to create mocap, and then I will apply. Right now, I'm retargeting from the standard skeleton animation to the retargetable asset. So if we take a look quickly at those are takes present in the FBX file. So this is a full clip that was captured. Sometimes there are some glitch. It comes from the mocap studio. And we see at the end of it that we have a backward. We just have enough to extract a backward walk cycle. So if we go back to the animation tab in the model importer, here. So you can split as many times you want your animation. So if you have a long take with a part where you are in idle, a part where you go from idle to run, you can create, add new split. So run right. Here I will add a new one that is called run right back. Whoops. Run right. Okay, and now what you want to do with extract, let me take this a bit bigger. You want to extract the cycle we have seen at the end of the animation. We want to extract this cycle. So here I'm just looking at the place where the feet, the right feet is on the ground. I will take the other side here. The other side of the... So here, I did it quickly, but you have you now have a cycling backward walk. I put the loop on. Look at the end. I will slow down the animation. So now I'm playing the raw section of the clip, and we see at the end of the animation that there is a difference between the first and the last frame. So you can fix this by clicking the loop. So now it will be smooth. And then we have many other parameters that let you control the trajectory extraction of your animation. So, for example, do you want to lock the root transform in rotation? In that case, it's not true because you have a turning motion. But do you want to lock your motion to stay on the ground? In that case, this is what you want. And then there are many other parameters you can tweak in here. One that is kind of really handy is the mirror. So right now I have a run right back. You can just click it, and now I have a run left back. So you can create split, rename it left. So this is quickly how you can create retargetable asset. You apply. Once you have done this, you can use the created asset just below here, run right back, drop it in a state machine, and start to using it in a state machine or a blend tree.
Which I'm going to show right now.
This is Pierre-Paul.
Thank you, Robert.
Yeah.
So once you have your animation, what you want to do is to create a state machine out of this, in an asset that we call the animator controller. Basically, what it is, it contains a layer of animation, and on each layer of animation, there is a state machine. So what I like to do is that I will start a new controller from scratch. So I have this little scene here with a character in it. I'm going to create a completely new animator controller. So here I am. Oops. New. So when you create a new one, this is the animator controller view. Currently what it did, it created a base layer, and this is the state machine that is on the base layer. Currently I don't have any state in the animator, so I will show you how to add that. So first thing first, I will set, I have an animator component on my character in the scene. I will set the new controller that I conveniently called new on this animator, and I'm going to press play. So since I have an empty controller, my character here stays in his relaxed pose. So I will add life to this character. So first thing, I'm going to add an idle animation. And you see, I'm in play mode, and I'm creating all this state machine, and it's done live. Just so you know, here I did a really, really simple script that is on this character. Basically, and I'm going to go through that real quick, I map the fire button to some parameters that I will set on my state machine. So it's a really, really simple script that I'm using here. So for now, obviously, it doesn't do anything since I only have an idle animation. I'm going to add what we call parameters to the controller. Parameters are the control structure that you use to talk to your state machine and that the state machine uses to talk back to you. So now I will create two new float parameters and a new bool parameter. I am going to name them direction, speed, and of course, jump, because we like to see our character jump around. So, for now, it doesn't do anything, but still you see the values here are updated when I play on the keyboard, on the joypad. So this means that the parameters are passed from the little script that I showed you into my animator state machine. So you see I'm always live linked to the controller. So now what I want to do is I want to get this guy moving around a little bit. So I'm going to create a new blend tree. I'm going to call this blend tree run. And in the blend tree, I will add 3 motions that were already created using what Bob showed us a couple minutes ago. I'm going to go into the run animation importer. I'm going to take the 3 clips, run left, run, and run right. I'm going to say one thing that we do that is nice is that we automatically connect, we select a parameter that is in the animator controller and we connect it directly to blend the clips in the blend tree. And I'm going to say that this blend tree, which has a run left, a run, and a run right, I'm going to use the direction parameter to do the blending. And I assume that the parameter will go from -1 to 1. So I will do the blending into this space. I'm going to press stop just to live link a little bit. So again, we can preview what we are doing. So now you see that. Oops. You see that when I move the direction parameter, we are blending continuously. Maybe I can make this guy a little bigger. Yes. So I'm sliding the direction button, and you see that we're blending continuously. One thing that we do that is, I think we are one of the only ones to do this. I don't know if you see it well on the projector, but there's a little marker here that follows the feet.
We see it.
You see it? Good. And we automatically detect what is the most stable feet at any given moment. And when we do the blending, we use this point as a reference. So when I do this, it always, even if there's currently I don't do any IK, but when I do the blending and there's a feet on the floor, it does the blending around that point. So you know, normally in games they would do the blending on the root joint, and you would see the legs, they would kind of wobble like this when you do the blending, but not with Mecanim, because we do some smart stuff like this.
And also all those preview, now we're looking with the default avatar, but again, we could look at blend tree preview with Naughty Bear, or we will also show you a transition preview. So all our previewer with avatar, you can preview it with your preferred motion.
I know that the bear is your preferred character, so I'll show this one.
I like the bear.
Okay, so back to the game now. So I have this idle state, I have this run state. Inside of the run state, I have a blend tree that I just showed you. What I want to do is that I want to connect them. So what I'm going to do is to create transitions. So I create a transition that goes from idle to run, and I'm going to make another transition that goes from run to idle. This is the transition previewer here, and it's also the place that we use to set up the transition. So what I'm going to say is that I want my system to take this transition if certain conditions are met. We can add any number of conditions for a transition to happen. So in that case, I'm going to say if the speed is greater than 0.1, I want this transition to be taken. Same for the transition that goes back from run to idle. I'm going to do the exact opposite. So this means that when speed is less than 0.1, I'm going to take back this transition. So now I play, and I see that the transition are happening when I leave the joystick. It takes the transition because speed goes lower than 0.1. Again, all live link. So if I play I can also live link the blend tree. So you see that there's a kind of subtle color shading of the blend trees here. So you know exactly what animation is playing at any given time. Now we want to have our little guy jump around. So I'm going to create another state for the jumping. So again, I want to jump from run to jump. So I'm going to create a transition here, up, and a transition back. I want to take this transition when the Boolean parameter that I created here, that is called jump, when it is true. So if jump, take this transition. And then we have a special condition that is called exit time. So when we are at 90% of the jump state, we will automatically go back to run. So now, I don't have a collision activated now. So you see that I jump. And it's kind of hard to see, but if I preview it, if I use the transition previewer and put it really, really slow, there's kind of a little problem that will occur in the legs. Maybe I should put it even slower. And oops, let's wait for it to happen. So we're going to see that the legs are going to cross, and this is a problem that really happens a lot during game development. And normally, it's really hard to get into this transition, try to find a way, you see there, try to find a way to have it in slow-mo and then find a way to fix it. But what we do, remember I showed you this little guy on the feet that we detect always what is the most stable feet. This allows us to trace what is the phase of the walk cycle or the run cycle. So we know this is the curve here that says what feet is on the floor at any given moment, left, right. Now he's jumping in the air, left, right. So you see that there is a phase mismatch here. So what I will do is that for this transition, I will start the run a little bit earlier like this. And now we have a really nice and smooth transition. So we have this guy here. Oops. What I want to do now, I will create an additional layer. Say hi. I will create a new Boolean event that is called hi. So what I will do here, I will create a state that has no motion in it. And I will create a state that has a motion, a waving motion. So basically what we do internally is that when there is a state that is on an additional layer that doesn't have any animation, it doesn't affect at all the animation. So this will allow us to do some nice stuff like I'm going to show you now. So here I'm going to create a wave state. I'm going to do a transition that will happen if the high button is true. So if I preview that, I must put some weight on this layer. So you see that on the second layer, we are going into a waving state.
Oh,
but
no.
you left it? Okay. So, but it's not ideal because now I completely lose the movement of the base layer. So you see now I'm pressing the joystick, and when it's not in the waving state, it's going back to the previous layer. So what I want to do is that I want this layer to be applied only on a certain body part of the character. So we have body mask. I don't really know where it is stored in the project. Right arm. So I have this body mask here that says only apply the animation on the right arm of the character. And then if I preview it, and again the live link, the parameter, it works two ways. It tells me what the animator is currently using, but I can also press the button to debug it. So here you see that I have the base layer that is doing the locomotion, and I have the second layer that does the high only for the arm. And even, you have to do some game logic to stop that, but I can jump while doing high, which is kind of really neat. So yeah, I think that's how we create really quickly. And I could have done this once you have your animation and you're used to setuping an animator controller, it can take as little as 5 minutes to do what I just showed you.
About the game
Thanks.
So this is a really simple state machine with 4 state, 2 layer. But with the game prototype we've shown you, it was a really more complex state machine. We have concept of sub-state machine, so you can group state together to have a more modularized approach. So the game was probably counting 200 state, many motion, and blend tree. So this is able to scale up. It's not just good for a couple of a state.
I did a sub-state machine here.
You did a sub-state machine.
Doesn't really do anything, but it's there.
Okay. So the next thing we will show you is how to use the IK. We have a default IK rig that is created on our avatar. It lets you control the 2 wrists and the 2 ankles, so you can grab stuff or reach the feet to reach the floor correctly without sliding. And you also have a look at that can affect all the upper body and the head to look at stuff. So where is my scene? Pierre-Paul shown how to use layer to affect part of the body. So in this demo, IK demo, to have something really nice, I should have used a upper body clip that would grab the bazooka. I'm using a cylinder to create mimic a bazooka. But in that demo, I'm not using any animation, so I'm using the same controller Pierre-Paul shown, so going left and right. And what I did, I created a script that let him hold the bazooka. I'm now using, I took this cylinder and I parented it to the head, and I'm tracking the bear that is somewhere. I just found, the bear is there. So I'm tracking the bear. I'm holding the bazooka with my two hands. And here I do a recoil. It's all IK. There is no animation, so I can just shoot him balls. I won't hurt him. It's just softball. But we see the recoil here. So I will show you the script I used to create this little IK rig. By the way, it's implicit, but for feet, by default, the IK is always active on feet. You can control this in the state. You can specify if you want IK for feet or not. And when it is active, it guarantees that the original animation feet placing is respected. So this is another use of IK. If I go to script, do you have Mono Develop?
I use Visual Studio.
C'est Visual
It's
Studio.
faster.
Oops. Okay, it's faster. Bazooka script. Okay, I put some game object to. Okay, how I did it? On the cylinder is parented to the head, and I put a handle for the left hand and the right hand, so I'm able to grab the cylinder correctly. Okay, a bullet object, the bazooka object. Here I'm doing. Looking for the fire event and fire 2 event. But what I want to show is the place where I'm driving the IK. With Mecanim, for each avatar, you have a callback called onAvatarIK. This callback is happening right after the retargeting, and it is where you can place your effector and move your wrist that was originally there to place it on the bazooka. So I'm asking the target position for the look at. Here I'm setting the look at position. The target is the bear, so I just drop the bear in there. And here I'm setting the look at weight. So I have when I'm loading the gun, the weight goes from 0 to 1 and it activates the look at. Here you have more control. You can control the weight that affect the body, the weight that affect the head, also the weight that affect the eyes, because you have eyes look at. So this is the API to control the head look at. Then if I have a left handle on my bazooka, I set the IK position to that left handle. I set also the rotation to that left handle, so my hand is grabbing the bazooka in the correct orientation. And then I activate the effector, because effector can be active or not. They are controlled with a percent value. So I'm also plugging this with the aim parameter. So when I charge, the aim goes to 1 and my guy holds the bazooka. I do it for the right hand and left hand. So this is the script that allow me to grab a couple of lines, and you're able to grab a prop. So then you can imagine any way to interact with the IK. So, yeah. Are you next?
No, you're next. The crowd.
The crowd. An easy one. Okay. So an avatar, you have evaluation of the state machine, blending of transform coming from the animation. You have retargeting. You have IK going on. So I will show you how performant we are, even if we are doing all this. We have prepared a scene that we call crowd. What I will do is spawn 200 characters here. So they have all their own state machine. If I press Control, I will start to spawn bears. So now, I think it's 200 or 250 I put in there. So they are all sharing the same controller, the same animation, and only a small part of memory is needed per instance. So you can really drive a lot of avatar without losing performance. Quickly, if I show the stats, can give an ID. Right now, I have 200 character. I'm running at 80 Hertz. So this is about Mecanim. You can put a lot of character in there. You can do IK on your character. You don't have to be scared that, oh, if I put IK, it will slow down my machine. Just put a lot of stuff and it will run.
Cool, thanks. So there's really a lot that we cannot cover, but because we would have needed 3 or 4 hours to show all the cool stuff that we can do with the Mecanim API. But there's a couple nice goodies that we can do that I want to show you. One thing that we have, this is called what we call the target match. Basically, what it allows to do, you can tell our system that you want to have a body part of your character to be at a certain position at a certain time in a state, and we will automatically cheat or modify the root transform so that you get to that position. So I'm going to show you how simple it is to set that up in our system. So what I want to do here is that I have a jump animation, a jump up animation, and I want my character to reach the edge of a container completely independently of the height of the container. So for those of you who tried that in the past, I guess every time I saw that in a game, they had a game design document that said to the artist that all your containers have to be 0.5 meters high or else the animation will break, but it's not the case in our system. So I'm going to take a jump up animation that we have already imported, and something that we can add in our animation in Unity is additional curves, basically to do markup or to do anything that can help you to control your character logic. So what I do here is that it's a jump up animation. And obviously, it's easier to cheat the root of the character when the feet are not on the floor. So what I'm going to find the moment in the animation where the feet are leaving the floor. So here I'd say around 26% of the animation clip, none of the feet are on the floor. So what I did, and I just did it a bit before the presentation, I created 2 curves in my animation, the match start and the match end. And it's curved, but it could be only, it's basically only constant value. So what I did is that I use that to do markup, to communicate to my other system what I need. So I created a parameter here called a curve named match start. I set it at 26%. So this is the moment that I will start to cheat the root. And then I look when my right hand is kind of getting stable. So again, around 39%. So here I have a curve that is called match end that is at 39%. Then what I did is that in the controller for this character, I created 2 parameters that have exactly the same name. And when parameters have exactly the same name, the Mecanim technology automatically connects them together. So what this means is that, for instance, all the animation that are currently played by our system that have those curves, we will blend those curves accordingly to the blend factor of the animation. For instance, if we are in a blend tree, we're blending a couple animations at the same time. We're going to blend the current value of those curves, and we're going to output them in the parameter of the animator. So what this allows me to do is to do something like that, where I have put some markups, we call that markups, on my jump up animation, and then I can use it to do some match targeting. So how do we use match targeting? Again, a very, very simple script here that I have. It connects the fire button to make the character jump, like I showed you. And single line of code. Basically, I'm telling my animator that I want the right hand of my character to be at a certain position. I'm going to show you in the game what is the right hand. Basically, it's a transform that I connected to the script. I want to match the position and the rotation of that target. I'm going to use the current value of the match start parameter, which will be the 29% that we saw in the curve. And the same goes for the match end. So I'm telling my system, I want that when I am in the jump up state, I want to start cheating the route at this time, and I want to stop cheating at this time. In my scene, I have this little object here. If I can click on it. I have this little object, which is the right-hand target, which I connected to the script that I just showed you. And what this allows me to do is when I press fire, the character will automatically go to the position that I want. And this is true even if I go to extreme values like this. Again, it's not exactly realistic, but just for the record, I had to show the lower one. Oops. So you're always sure that your hand will be at the correct position, and then since the animation is done accordingly to that, after that the feet will automatically get at the current position. So this is one nice thing that we can do with our API. Another thing that is nice is what I call having my character jump through hoops. So here I have this guy that is facing a brick wall. These are rigid bodies here. I have a little hole in the wall. And normally, if I press play, and I have a very simple state machine, it's only an idle with a dive animation. So if I press the jump button, it's going to break the wall. And the reason for that, if I press play while selecting this, I'm going to see the character capsule here that I use in conjunction with our system. So it breaks the wall. So I don't like that. I want my character to jump through hoops. So what I'm going to do, I'm going to look at the animation, the dive animation here. And again, using the power of the curves that I can add to the system, I just created a small curve that offsets the scale of the capsule. So you see that when she starts jumping, I want the capsule to be scaled down. And when she's done jumping, I want the capsule to be exactly at the same scale as before. Again, very simple script. I change the height of the character controller accordingly to the scale offset that I get from my curve. And you know, I can call this every frame, because if the scale offset capsule curve does not exist, for instance, in the idle, it will return the default value, so it's 0 if the curve is not present in the currently played animation. So I did some thing to make it work. So you see here that I always call this completely independently of the state. So it simplifies also game logic to have that. And I'm just going to turn it on. I will have my character jump through hoops. You see, getting smaller, fitting through the hole, and I have a character that can not break wall. So that's it for that.
Yeah. Cool. Additional curve, Pierre-Paul used it to go through the wall without breaking it. But if you want to mark up where your feet touches the ground, or if you have a grab animation, if you want to use a curve to activate the IK, just when I come close to the bottle and grab the bottle, this is kind of an additional curve you can add to your animation.
Another good example is for a lot of studios are using in-place animation. So you can, for instance, if you buy an in-place animation from the asset store, so maybe you don't have access to the original FBX file, you can, using those markup curves, do the root transform. You can author in Unity the root transform and then play it back with a very, very simple script.
So now, all we've shown you so far is Mecanim animation applied to humanoid. We realized that all this tech machine setup and all this nice technology, it would be nice to use it on other things than human. So we are currently working on a new build that will allow Mecanim to work with. Where is my? Can you just stop the Pierre-Paul, please? So yeah, for 4.0, you will be able to drive any kind of skeleton structure with Mecanim, not just biped. And we have built a little demo. I'm using Mindbots from AngryBot demo. I took the animation directly from AngryBots, and I created a blend tree, a small state machine that I will show you in a couple of minutes. Second.
So this is brand new. I think it's the first time that we show that to a...
Yeah.
It's a...
We are rushing this in 4.0 so people are able to drive other things than human. And also, it's not just driving generic skeleton. If your human have some props, for example, wings or additional thing animated on your human, it will also map, and you are able to drive more than just the human bones. So this is the idle of the Mindbots. Now we are playing the blend tree. It's the same blend tree Pierre-Paul shown. Now I'm using playing the animation. So also we have shown preparation of animation clip. If we select a clip, you can also preview the animation like you do for humans. So Pierre-Paul was talking about in-place animation. This is all in-place animation. So in the script, we attach a rigid body to the Mindbot, and we are setting the velocity of the Mindbot based on the direction. So this is the motion. And if I start the game, you will see that I land on a cube, so the rigid body is colliding with the cube and will collide with the plane. And now I'm setting the rigid body velocity to... so this will be part of 4.0. So it covers what we wanted to show you today.
I think we have time for questions, so
yep.
Just feel free. That was
great. Can I ask, this last thing, you can create your own bone structures that have nothing to do with a biped.
Yep.
Would that easily cover a face bone structure then and do face animation?
For 4.0, what we are doing, it's skeleton bones. Eventually, we will drive any kind of animation, but if you have a face, a bone rig for your face, Mecanim will be able to drive it. We just take the animation and the model that are in the file, and we drive those bones.
Okay, at one point when you retargeted the animation from the dude to the teddy bear, it looked like there was some self-intersection on the model. So I'm not sure if that actually happened or not. So the first question is it possible that some model self-intersection can happen when you retarget? And if so, how do you suggest dealing with that?
Okay. You're right, probably there was some interpenetration. I've shown quickly how to set up an avatar. I've shown the muscle where the teddy bear was doing the stretching. For each muscle, you have a range. It's not a limit, it's really a range. It defines the range of motion of each muscle. So teddy bear, we could have just reduced the range so when the muscle goes down, it does not interpenetrate with the body. And then after, if you have more problematic use case, you can use IK afterward to place back hands and feet if they are.
And just to add on the muscle range, something that we can also do with that is quite nice, is that you can really add some color to your animation. For instance, if you want to have a guy that is really, really stiff, you're just going to change the range of its muscle. So he's going to walk like a little bit like this. So it can really add color. To the limit, you can also do this for a single arm. So if you want his right arm to be really stiffer than the other one, you just use the muscle limits and it's going to work.
Can I ask, is the IK, is it being done by least effort, or on what basis are the choices being made of the inversion?
The IK algorithm?
Yeah?
We start from the current FK pose. The FK pose that come out of the state machine, the IK will find the solution starting from there. But at the end, it's a two-bone IK algorithm. But let's say your arm is like this and you want to reach that point, it will go that way. If it's like this and he wants to reach a point, so it's kind of least effort. But the idea of the IK is to be...
As few joints as possible then.
Sorry?
Basically as few joints as possible then.
I'd support 2 joints. The IK is for a human arm and legs. So.
Okay, thank you.
First of all, congratulations. It's mind-blowing.
Thanks.
It's really great. The question that I had was the jumping through hoops. It's very nice that you can disable the physics, but he was still going through the mesh of the boxes of the wall, right?
I did not disable the physics. I scaled it down a bit. So.
But basically, you just disable the physics, quote unquote. But would it be also possible to actually make it that it goes actually through the hole?
Okay, you're saying that we were hitting the wall at some point?
You were still going through the mesh.
You know what Pierre-Paul shown, the trajectory, to match a trajectory, you can match with a mask. So in that case, you could match just the Y component of the jump, and for that specific time, you could lower the point so it's sure you would go in. So we could do all that is moving and always jump directly in it.
Yeah, so you could also make it that even if you have an up and down moving wall, you would still go nicely through the hole. Fantastic.
Yeah, the match target can be done in real time. So
great.
Just a small question. When you were extracting the clip from the backwards loop, is it in any way possible to export that out of Unity again?
To export the created clip?
Yeah.
It's an asset that will be on your drive. But there is no workflow to export. It's to be used in Unity. But yeah, there is no way to export back, I think, from Unity anyway, elsewhere. I'm not sure. We're kind of new at Unity, but no export workflow.
Thank you.
Is there a way to trigger some event or some particle system or sound at a given animation transition or at a given frame of the animation? And if not, is there a workaround to have this?
There is many ways to do this. Some are workaround, but the curve we have shown, you can draw a curve, and when you reach certain value, you can trigger particle or sound. In the demo, the prototype game, when the guy is running, you're supposed to hear the sound of the feet on the ground, but we were not having audio. They were using that technique to trigger sound. Then if you want to do it on a transition through C#, you can always ask the avatar what current state he is in. Is he transitioning? What is the name of the current state? What is the progress on the current state? What is the progress on the current transition? What is the next state? So you can know exactly where you are in the state machine and trigger effect from the C#.
Is there a way to name some frames, for example, or to define some intervals in the animation to be sure that the script will, when running, will fit within the time frame?
Sorry,
to be sure that the function, if we have some behavior to trigger at a given animation transition to be sure that we fit this transition, because depending on the frame rate, maybe we don't fit exactly the...
No, but eventually we will support the real event, the same event that is already in the old animation system. I don't think it will make it for 4.0, but I understand that using curve, there's kind of a frame rate issue here that you can just...
Okay, but for the transition, it's clear that if you do a transition, no matter what is the frame rate, you will at least have one call in that transition. It's impossible that you miss the transition. So if you want to take decision based on transition, this is something guaranteed. But like Pierre-Paul said, supporting real event in the curve, this is something that will come.
Okay. Thank you.
Hello. First of all, thank you for the awesome demo. I really loved it. But is there any way in this system, is there any place for additive animations?
For what?
Additive animations.
Additive animations?
Yes.
Okay, the layer, when you add a layer, you can set a body mask, but you can also specify if it's an override layer or if it's an additive layer.
Okay, thank you.
We've hardly find good use of additive animation other than doing breathing, and I'm gonna take 2 minutes just to show you what I mean. And what is nice about the way that we actually implemented additive animation is that we convert the animation clip runtime. What I mean by this is you see here I have the high layer that I was showing you, and I can make it now it's override, and I can make it additive. Just gonna. So you see, when we're in idle, it's kind of okay to use additive, but whenever you start doing other stuff, I find you see the result is kind of awkward. It's kind of sneezing instead of saying hi. But yes, we have additive animation.
So a question about preparing assets to go into Unity. I'm assuming that the process is still just a standard rigging in Max or Maya, and you're waiting, and then you're ready to just export FBX right into Unity?
Exactly. You don't have to change the way your artists are working.
Okay.
We use the same rig. The retargeting occurs in the model importer.
It's fantastic. Great job.
I was wondering about the let's say you have two different FBX. One is running and one is waving. And if you retarget one of the animation to one of the FBX, and if you make a build out of it, would the other FBX also get included into the memory in the build?
I need a repeat on this. Sorry. And where are you? I don't see. Okay. Sorry, could you repeat it? It was a too long question.
Yeah, so basically, let's say you have two different animations. You made two FBX out of it. One is running and one is waving. Now, if I use the running avatar and then I retarget the waving to the running model, now if I made a build out of it, would my waving model and running model, both of them getting built into the executable, or would it just be one of them getting built into the executable?
You mean the animation asset that is produced?
Right.
Right now, there is no mixing of animation asset. An FBX can produce a series of animation asset, but there is no blending. We take part of the animation that is in the FBX and we create animation with it. So I don't know if it's answer your question. Okay, cool. I will talk about retargeting then. Compared to other retargeting technology where you do, you have kind of a reference skeleton and then runtime, you retarget to the destination skeleton. What we do here is that we do one part offline, taking the skeleton animation, and we create an animation clip that is a normalized animation clip. Our animation clip, they don't have any skeleton binded to them. They are the muscle channel I've shown you. The muscle clip is the animation on those on those channels. We also save the trajectory of the mass center and the position of feet and wrist. So this is the first part is taking the skeleton animation, creating this generic animation. This happens at importation. But the other part where we take this normalized animation and we apply it to the destination character, this is what happened in runtime. And the blending in the state machine, we are also blending in that space. So the blending is better than trying to blend a layer angle on a skeleton. It's a brand new animation asset. You know, when you create this animation clip, we first read the current, at every frame, the pose of the skeleton, and we create we call it a muscle pose. So it's all those muscles that matches that skeleton. And this is what is saved in the animation asset. So when we blend in that space, and then the retargeter is after the state machine evaluation, and we finally output to the destination skeleton. So I don't know if it answered your question, but we'll be at the hands-on tomorrow. If you want to talk with us, you can expose your problem there.
Cool. Thanks, guys.